our next speaker is Mike Newcomb. Mike is the CTO for the Higher Education Strategic Vertical Markets with Juniper Networks, in particular with the higher ed and state local government group. When we wanted to put together something for IT Matters, we were trying to figure out what the best thing was to use, what was how best to go about, what topics, what we want to do, how we want to present it. And we wanted to talk about wireless AI was one of our topics. And we wanted to look at an application of that and how that could work in today's environment. And we reached out to Mike at Juniper and said, hey, would you be willing to share? What do you think? And what Mike came back with was a presentation that I think is going to be really interesting. I think you're going to find it very interesting as well. And let me say that while the topic is emerging AI technologies in higher education, and while Mike is looking at wireless and looking at higher ed, I want you to put your hat on and think about your thinking cap, and think about your sector, your vertical, your organization, and how these ideas that he's going to share could apply to yours. Because frankly, while we are talking about higher ed as the sector, these ideas and these technologies would apply all across our region and all across our country. So Mike, let me bring you on and give you just a second to get set up and start sharing. And I appreciate it. I think you're there.
Yep, I'm here. Can you hear me, Michael?
Yeah, perfect. Thank you very much for your joining us today. I think you have screen sharing capability, so
yep.
There it goes.
Perfect.
I will turn it over to you. Thank you very much.
Thank you, Michael. I appreciate the opportunity. As Michael said, I'm the CTO for the Higher Education Strategic Vertical here at Juniper Networks. And it's a position I really love because I've always been in my career. I mean, I go all the way back to Burroughs, if you notice my gray hair, but I've been in networking forever. And at the same time, I've also been an adjunct professor forever, for almost 40 years. So I get to feel this on both sides of the fence and what it takes to have an application affect you or a network affect you as well on the teaching side of things, as well as what it's like as the one that wants to hopefully change how universities architect their networks. So I'm going to talk to you a little bit today about the emerging AI technologies in higher ed. And the reason I'm going to talk about this specific is that networking companies in general are going to have to make a transition. AI and machine learning make a huge difference when it comes to operations. Just listening to what Jacob was saying in terms of what it takes to do some things and working with Puppet and Ansible, Chef, all those things, it is something that the typical networking industries companies have to do, right? That's how you configure switches in those worlds. About 2 years ago, we purchased a company called Mist. And what I want to tell you about Mist is that they were built by these guys from Cisco that had left Cisco. They're the ones that did Airwave and Meraki. They were the thought leaders in that, and they felt they needed to go off and start their own business, to the point where Cisco even were an angel investor. But instead of going off and trying to design a wireless network based on the same old technologies that everybody else has been doing, which is controllers and all this, they said, what if we just tore up a piece of paper, started blank, and started with the customer's experience first, understanding that, I guess at the very base level, that sometimes the network can be up, but the experience is bad. So what happens if we focus on the experience and not on the equipment? And then everything will come from that. Now, they happen to use wireless, and they've put in the latest possible technology which I'll explain to you, because I believe other networking companies will have to follow suit at some point. But they built the whole system around AI first to be able to allow us to take it. So when we bought them, they had a lot of people offering, but they actually came to Juniper because in our operating system, the way we look at things and the way our whole network is, we have a very open operating system called Junos that allows you to, it doesn't matter what the device is, to configure it. They felt that they could get the best bang of the buck for AI based on that fact alone. They thought they could get their vision of AI and the customer experience injected very quickly. And so far, that has been the case. In fact, when you look at how we look at the world when it comes to AI driving your network, it is about focusing on the user experience first, right? And you can see all the things that have been done here. We've already gone from our AI experience affecting the wireless piece, which was already league leading, to the point where now it affects the wired space, where insights and experiences are shunted up to a single cloud, this cloud engine, um, to allow us to be able to understand the experiences on the wired network, to also extend to our security network. And very, very soon, we just started releasing everything on our WAN network, and eventually we'll have it in the data center. So the pivot that Juniper has had to make has been to understand that the traditional way of doing networking, where you buy equipment and you stick it on a wire and you try to get it all to connect up, isn't the best way to experience networking, right? And so this whole setup has been not so much from the equipment that was purchased, even though it is the best in the industry. It's because of the experience and the usage of the AI piece, which is now basically propagating throughout everything that we do at Juniper. So it's the biggest pivot I've ever seen in networking in my 40 years of being in the industry. In fact, this whole effort with this has been recognized even by Gartner, right? This is impressive for a company that we bought 2 years ago to be now the #1 score for WLAN access. And because of the fact that at the time we were already starting to do things in wired, it ranked us up there too. So the 1 and 2, basically the best of breed for wired and wireline has been, according to our good friends at Gartner, is us. And you'll see this reflected in some reports that'll be coming out. But the point here is that it's not so much the equipment, it's the vision and how to implement AI across the network to make your customers' experience better. And when I say experience, I don't mean just I get on the network and I can get to a server. It's everything about how it changes the platform underneath for you. So to give you some quick use cases and understanding of what's happened and what's this dynamic change in the industry has really come because of this experience with AI, and it has affected people differently, right? And you see 4 little examples here. For example, Walmart, 80,000 APs, they're Fortune 1, right? And if you look at those people and you knew what they had before, when they recognized what could happen with our Wi-Fi product Mist and the AI implementation and how quickly they could do it. And I'll explain a little bit the difference between these architectures in a second. But when they realized what could be done in terms of the microservices and things that they could do to quickly implement 80,000 APs, there was no contest. And in fact, it was the AI piece. When they realized what we could do with our AI engine, they said, "Are you going to do this with your switches?" And we said, "Yes." And so they immediately started deploying our switches. So now Juniper is the de facto standard here at Walmart. You had a different view of it at ServiceNow. ServiceNow, again, when you look at the traditional way you do networking, their biggest driver in Wi-Fi was the fact that they probably had 100 trouble tickets a month very easily, at least 100. And what they were able to do with AI, again, with the AI engine that we have, is to drop the number of tickets down dramatically down to 2. Because now what happens is, as things happen, it's immediately diagnosed in the cloud, it's diagnosed by the engine, and it immediately lets them know what is happening on the network, right? And so it's proactive instead of reactive. The days of having to dispatch somebody out with a wand to go measure the signal strength and to determine why is the green light on but my experience is bad, that's kind of gone away because we already know about it before they do, because all these experiences are constantly being communicated on every access point to the cloud. And so again, AI needs data. Being able to take, in our case, 150 data points per device every second and have all that data up in the cloud is important, because those are all experiences that we can use to learn with our machine learning engine. And the last one I'll tell you about is Amazon. Amazon, was a situation where they because our AI engine had gotten smart enough to understand things that had happened from another customer that was in the cloud with Amazon. When we were actually doing demonstrations with them, they realized, did you know that you are missing all these VLANs on these switches? Amazon's first response was, there's no way. We got all these CCIEs. We know what's happening. And when they saw that we were able to show these VLANs, and in some very near future, we're going to have VLANs that just be fixed automatically. But it's one of those things that you see that it was very quickly diagnosed. He says, you've saved us probably months of investigation on what was going on to just find a simple thing like a missing VLAN on a single switch. So these are all kind of important references in terms of different applications of AI and how it has affected them specifically to be able to increase their service levels, to drive their operational support, make that simpler, be able to do more. And then and again, I know I said Amazon was the last one, but you'll see here in a second about MIT, which is very near and dear to my heart, which is them doing it because of the Bluetooth and contact tracing aspects of this. And so we'll talk a little bit about that more in a second. A lot of notable enterprises. So the first thing I want to do for you is to kind of highlight why this change has to come, especially for university settings or any setting where you're trying to control your costs. You know that there's a lot of complexity, and the enemy of cost containment is usually complexity. And if you look here on this diagram, you can kind of get an idea of what the existing architectures look like. And what happens is that these architectures in the current world, based on this third generation way of doing Wi-Fi, is pretty complicated, right? You buy your access point, which is mainly a device to get you on the internet. And those devices require controllers. Those controllers require a controller master to control the controllers. Anything that you want to do extra, anything, whether it's management, telemetry, being able to put virtual or beacons out there, require additional equipment that has to be managed separately in a separate cloud. You have to have more servers on site to be able to deal with your appliances, your analytics, and your data collection keys. All of those are going to different clouds. So that's on the left side of this diagram. You'll see that this is a very complex thing and has to be very detailed managed for any individual company or university, in my case, that's out there. On the right-hand side, you'll see that that complexity really lends you to a dependency between these devices, that you can't necessarily take advantage of a new update because something else might break. If you look at this architecture, these are all dependent on things kind of going up at the same time. This is why when you look at a controller architecture, you'll find that the controller architectures are very fragile. In fact, when it comes to fragility, you'll see that they probably don't update the controller stuff more than once or twice a year. And again, the purpose of all of this is just to get on the internet. There's nothing special that can happen without additional side-on, bolt-on types of things. So that's what when the people that created Mist left, they said, we've got to fix this and make this all simple, where we don't have to do have so many interdependencies to have to worry about. Now, this next slide I'm going to show you is how we are looking at things. And again, I believe that other companies will have to move to this because it just makes fiscal sense in general. And so instead of having you as an entity by itself sitting in your bubble of what happens on your network, being you have to find any errors that are happening, you're in that mode of I have to respond to every trouble ticket initially by myself, go diagnose things, which takes money, time, just to keep the lights on. The whole architecture has changed when it came to how we started looking at the world. And that's to put everything into a single cloud. The single cloud exists because all the data can be up there. It's secure, it's safe, but it allows you to be able to analyze things that you can never do. In addition to just the data of the telemetry of the devices and things that are going on the device itself, you need to be able to have something that can access it. And so, for example, on the left hand of my screen here, you'll see Marvis VNA. Marvis, if you remember the Marvel action series, right, with the Avengers, Iron Man had Jarvis. Well, that's kind of where that came from. We used Marvis, but it's our AI engine that uses the machine learning underneath it to understand what is happening in the network. And the really neat thing about this is the experiences that are taking place in the network are not just your company, one company, it's everybody. You're getting the shared experiences of what is happening at Walmart or University of Texas, Arlington, or University of Texas, Dallas, or Dartmouth, or MIT. They're all up in the same cloud. And as Marvis detects and is able to solve a problem with the machine learning algorithms that we do, it gets smarter. And this is where I feel very confident that people that are just now starting, they got 2 years of experience to try to figure this stuff out, because machine learning takes experience. And this is what's happening here. In addition to this cloud, and I'll talk a little bit more about this in a second too, you have what are called microservices, the ability now to transform the network from just being a method of getting on the network to be actually being an asset that you can rely on for more things other than how am I getting on the network and can they get to my servers? This is about being able to have a heterogeneous way of looking at the entire network at one time, be able to write applications that can take advantage of the data and the machine learning that's going on in the background to provide some very interesting applications like contact tracing, like roll call applications in university settings, things like that. So, and I'll talk a little bit more about that in detail. The whole idea here is that all this is in the cloud, and whether it's wired or wireless, we're able to manage it all from a single place. This also gives you one other huge advantage, in that it's about the ability to have zero touch provisioning on everything. If you've ever put in a wireless network, even just for a point of a proof of concept, we were just in one where we were late to be invited, and everybody else had about a 2 to 3 week advantage. They were already putting their stuff in for 2 and 3 weeks. We showed up and put it in a half a day, and it was up and running, ready to go. And they were so shocked at that simple thing of being able to just immediately put something in the network, and it was up, running, fully efficient in less than half an hour. It was amazing to them, and that's ended up why they decided to choose us, because just the functionality of being able to do this is a big deal, and the fact that it's in the cloud is a big deal, because that's what enables everything to happen. It's all there and it makes it easy. By the way, this also gives you one other opportunity. That is the ability to consider people that are in remote work situations, which I'll talk to you about at the end here, to really be a true extension of a university or corporate setting without having to have VPNs, because we treat every device as something in the cloud as a remote session. Makes it very, very easy to manage, makes it very easy to diagnose what's going on for individuals. Now, this whole thing with AI and machine learning is based on this, and this is where we know what has been happening in our networks, right? We know that there's connected devices that are just going out the door in terms of how many connected devices people even bring to the table. You're talking 2.6 billion devices. At the same time, you get these applications that are continuing to be created to where you've got over 88.7 exabytes a month of data that's related to as far as the data bandwidth required to do these apps. At the same time, you have the situation of thinking to yourself, am I going to get more people to deal with all of this control and all this? The very fact, as I mentioned earlier, that our devices per access point is watching every single connection, whether it's connected or unconnected, and sending up 150 data points into the cloud, whether they're connected or not connected, into the cloud. There's absolutely no way that you would want to have any engineer sit there on syslogs and try to figure out anything, because this data that's up there is up in the cloud, and you need to have something like an AI engine to control it, to be able to make sense of it, to take the machine learning and just take its outputs, right? So the benefit of doing AI in the cloud is the ability to be able to allow your teams to stay flat, or whatever the status is, and let them focus on the more important things like driving new applications and things, and not worry about how much time has to be considered just to keep the lights on. Now, we're sitting here in a pretty unprecedented time. I think we all know this, right? And I deal with this on a regular basis. In fact, my number one presentation that I am asked to give to universities across the US is on contact tracing. And so I've got pieces of this I'm going to talk to you about because AI affects this. The ability to truly do contact tracing is to make sure we understand and what it means and how it applies to creating what I call a defensible campus, right? The point of this is to minimize COVID-19. It's really about distance, keeping people 6 feet apart. But realistically, it's also knowing where they've been, right? And so COVID-19 has caused us to relook at our networks and how they work. In fact, as I go forward and I look at how things are happening in universities, these are all questions that I am asked on a fairly consistent basis. How can I get my students back to campus safely? I think you've already seen there are many situations where people have come to campus and they thought they were going to open, and then COVID started spreading around because I think we all know that a lot of times students are not the most careful about this stuff. And then suddenly they're sending all their students home, or they're having to deal with buying hotel space to be able to hotel them so they can quarantine for 14 days. There's a lot of changes, right? And we still don't even know what other government mandates may be coming down the path. The one thing that I know that I'm talking to CIOs and CTOs has been about the legal ramifications of not even having a plan. Some people just say, well, the government will tell me what to do and that's what it is. But if you have a situation where a student has a untimely demise because of COVID and you don't have anything that can help protect them or at least show that you have a plan in place, that does expose the university, in my case, with with liability, and that's something that we don't want to tolerate in these days, right? So it really comes down to understanding what has to happen here, whether you're staying at home or pivoting back to teaching classes online again, like I've done, or and really taking a close look at your network and understanding what else can happen uh, versus a network that's just based on let me do the same old. Here, you get on the network and I can give you access so you can watch Netflix. That's kind of what we have. So, at a governmental level, I do want to make sure you understand the differences of what's going on out there. There's a lot of talk about manual contact tracing. In fact, a lot of people have actually used money from the CARES Act to be able to go and say, I'm going to hire contact tracers with the whole purpose and for them in terms of being able to say, okay, I'm going to sit down with this person. Who have you talked to in the last 2 weeks? It's a very manual process and it's very difficult, right? And so there's the macro aspect of this, which is what's happening with Apple and Google versus what I'm going to tell you about, which is how do you create your own defensible campus. So if you're talking about what do I need to do to create that defensible campus, you really have to ask yourself some questions. And again, AI plays a hugely important part here in our wireless product of how we have this platform plays an incredible part of being able to deliver this than anything else that's out there today. Being able to understand how long somebody has been on a campus and where they've been, who did they come in contact with, what zones, were these in, where have they been and who they've been in contact to is probably the most basic thing that contact tracing has. To be able to understand that and have a record of it for over 30 days is pretty much going to change what people are trying to do in terms of creating that campus, right? And then what about proactive things? Are there things that you can do to make sure that people are obeying the rules for the campus? Is there some things to be able to warn people to not go into certain rooms or certain areas? For example, is it safe to go to the cafeteria today? And be able to have an application that you just push on your phone and it says, get right now, it's a red zone. I wouldn't go to the cafeteria, too many there. Um, and then even to identify where people have been, where you say, you know what, I need to do some additional cleaning. Or if somebody has been diagnosed as COVID in an area, instead of closing down the entire campus because you don't know where they've been, now you're able to just focus on the areas they have been and maybe do the additional cleaning and disinfection necessary. So the things that you're going to see out there in contact tracing specifically is this whole API concept, which if you look at your phone right now, Apple and Google have now placed on your phones. This is my phone actually, where you see the COVID-19 exposure notification. It just showed up in an update one day. And it's basically something that they're going to do from a governmental standpoint to somehow let you know. Now, this is an app-based service, so somebody's going to have to build the app and be able to somehow correlate what's going on, right? So this is kind of the beginning point, but that's not really what it's about, right? Because this particular solution is a macro solution. It's okay that the government and the counties or the states are going to come up with a system to try to notify you about the external sources, but it really doesn't help you to decide whether you should even open your campus back up, whether you should allow employees to return to campus. And really, if you're an enterprise, you have no control over the data. It's whatever Apple, Google does with this corporation thing. So it just doesn't provide you the details you need to help you make a decision about your campus. And that's why the talk I give is on this whole defensible campus concept, right? So that leads us to another piece. And that's here in the Apple Google partnership. The second part is the most interesting thing to think about. They have made the decision that Bluetooth is what is the way to do this. Now, Bluetooth has a lot of very good reasons why it's the best way to choose contact tracing applications from, because Bluetooth can give you a more precision in terms of the locations and where people are, right? It's a lot more robust than just an API where somebody's notifying. This is about being able to have the ability to track a device or sets of devices anywhere on a campus, because Bluetooth is always chirping away. In fact, what we have here, in the case of MIT, they also looked at Bluetooth. So again, that key word has popped up, Bluetooth, Bluetooth, and Bluetooth, because of the characteristics. And so what MIT was doing was they got together with Carnegie Mellon and Mass Gen and Boston University, Brown University, and they started developing an application called PACT, where they're listening for these low power Bluetooth, chirps that are coming from the phones and everything else in there, and they actually take it. They kind of make it anonymous. You opt in, and then they go to them to the point of saying, if we do find somebody that happens to have COVID on the campus, we can notify them. Well, this was when they first started doing it, and now what you have here, and this is where AI came in and it made their decision for them, I guess. The CIO is on record for actually saying that when he saw what we could do with the Mist platform, the Juniper Mist platform, he said it was like a dream come true, because he was really looking at how do I create something myself, right? And so even though he had just purchased over 1,000 devices from another vendor, he basically said, nope, this is what we have to do. And so the access point that he purchased from us has this Bluetooth directional array in it that's part of 3 antennas. There's the Wi-Fi antenna, there's this omnidirectional antenna, which has all of these points to provide, again, all Bluetooth isn't the same. This is an array that gives you the ability to hyper pinpoint where people are on your network at any given time within 1 to 3 meters. They bought these 9,000 access points and installed them in less than 3 months. So I want you to kind of consider that impact of AI again, because I know that's the kind of the tenor of what we're talking about, but it takes that cloud-based zero-touch provisioning to be able to do something at this scale and do it within 3 months and have everything up and running. So as we dive deeper in terms of what is possible when it comes to proximity tracking, you have to understand there's 5 different pieces that go into this metadata. This is just general, right? If you're going to do something, you need to be able to address all of these. Whether it's an app-based service that you have, a Bluetooth tag that you might use, a passive BLE, basically just something that can listen to when Bluetooth is chirping away, to connected devices on Wi-Fi, to even unconnected devices. And so when we at Juniper looked at this, we said we need to combine all of these sources of metadata. This has to be done, because then you can provide a true picture of what's happening on your campus. And so this AI-driven solution works by combining and allowing you to start with Wi-Fi, create a Bluetooth app, or use a BLE badge, one of these little $10 Connect.io badges that are put on the back of a student's ID now, in some cases, to be able to provide you something that says, here's this person's device and where they are on the network. This has to be combined with something that can deal with standard-based Wi-Fi, virtual Bluetooth low energy, and the connection to IoT sensors such as temperature sensors, gunshot indicators, whatever is there, and have them be connected directly into the network to support a campus-wide Wi-Fi setup, right? All of this is nice from a hardware and software standpoint, but the thing that enables all of it to happen very quickly and to give you the flexibility to pivot to whatever is needed at the time is the cloud microservices that gives you zone-based analytics, hot zones, journey map reporting, proximity tracing. And I'll show you some quick examples of how that works in terms of the way that we do things at Juniper now. Keep in mind, there is a privacy thing, and I don't want to underestimate this part. The whole thing that we looked at when we did this was we're not collecting people's names. We see devices and what they're doing. It's the job of HR or whoever that says, okay, if a student has COVID, they would have the master list of the devices out there to be able to say, here's the device and what's happened with it on the campus and where it's been, so that you can notify all the people that have been around. Again, this is automated contact tracing that can be done versus a manual person doing an interview trying to look at it, right? This is, again, the value of AI and a cloud-based system to be able to provide that kind of information. Now, when you look at trying to implement this into a real world scenario, right? Everybody kind of starts with Wi-Fi, and that's what you'll see. Anybody that's doing a contact tracing thing. But the problem with just doing Wi-Fi and trying to say I'm going to do contact tracing is that the accuracy is at best 5 meters, but it's more 10 meters and beyond. If you've ever tried to look at your phone on on where it is based on Wi-Fi, you'll see it just bounces all over the place. And that's there. It's easy to deploy, but you can't really depend on the fineness or precision of the location detail. Well, we look at saying, well, you can have Wi-Fi. That's okay. You need that. That's a good point. It's one of the five metadata factors. But you also have the ability to say, let's give people that are on my campus a badge, including visitors, by the way, where you can correlate what's happening. And so this person with this badge, the badge is always on. You're getting 3 to 5 meters, closer to 3 in most cases, and you're able to have that and understand where they are on a campus at any given time, right? This impacted badge can then be reported to HR for at-risk employees, and you're able to then inform everybody very quickly where that person's been and how long they dwelled and who they were in contact with. And the last one that we deal with a lot is now people just having the mobile app running. So when they're on the campus, we say run the mobile app. Again, keep in mind, this doesn't mean that you have to always be logged in to make something happen. In this scenario, you always have the badge, but in the case of the app running, now you even get better accuracy. You've got bidirectional communications. You can warn you can warn your campus people about things that are going on very quickly. Campus security is able to quickly correlate where you are on your device from a security aspect in terms of maybe something going on in the campus, let alone just these are where we're recording this data for 30 days in the cloud and knowing where it is, but it's also real time at the same time. Now, when we talk about the best practices for contact tracing, it's kind of important to understand that a lot of things can make it more muddier than it looks, right? And so you have to have the ability to be able to filter through the fact that, if somebody's carrying 3 devices and they're all on, MacBook, your watch, your whatever, it can muddy up your diagram because it shows maybe too many people there. So you have to have something that has the capability of really sorting all this detail out for you. And so this is a real-time view of our Sunnyvale campus. We can see all the Bluetooth devices that are on there. You can also see the app clients that are actually connected to the Juniper network. Right, so you've got the cellular connections, you've got the Wi-Fi connections. In purple, you'll see the Wi-Fi clients. But what's really interesting, you can also see the unconnected clients. So just the fact that somebody is on your campus and they may not be connected to your Wi-Fi network, you're able to at least understand where these Wi-Fi people Best of this is the BLE clients, which we know are very significantly tracked in terms of their proximity because of the 1 to 3 meters, as well as being able to mark things that are assets like a expensive printer or a copy machine or whatever. It's able to be tracked through the use of this device and our platform to be able to see where it is. Definitely opens up the art of the possible in terms of what you use it for and how you use it. The second best practice is the user journey map, the ability for you to be able to know by zone, and think of this as a zone as being a room. It could be a floor, it could be an area, however you want to define it, but you're able to now look at where a specific device has been and how long they dwelled. This is just a standard dashboard report we can give on any specific device going on, because again, AI is making sense of all this data. It's able to correlate where everybody has been, what they're doing, who they're in conjunction with, not you having to take a spreadsheet and sort it and try to figure this out. This is this reportable information on a live action basis, right? So in this case, if you see this device here, this visit that happened on March 3rd, 2020, you can see that from the period from about 120 or so till about 5, you can see where that person has been. And if this person was deemed to have had something, you could go back 30 days and see where this person has been. And now you say, you look, these 3 floors, 4 floors, I'd say we should really clean these 3 to make sure that everything is mitigated. You can, with a great deal of precision, where the affected areas are that you can go after and make sure it's more sanitized than the other areas. So this journey mapping makes a sense. You can see these circles. They basically tell you how long. The bigger the circle, the more time they spent. Very quick visual about where somebody has been. Now, the next thing is, again, confidential, but it's the confidential correlation that can take place very quickly. And so to understand how long somebody's been in a zone is one thing, but to understand all the devices that they've been near over the last 30 days within a proximity of 1 to 3 meters is something that, again, we can easily do. And now you're able to go, if you know that there's a situation where a individual had COVID, HR can go in, they can say, hey, this device has been related to COVID. And now you can go and inform every single person that they've been in proactively to tell them if you develop symptoms, you may want to quarantine, you may want to get tested, just to help them be ahead of the game versus finding out they had it and they've already spread it to 5 or 6 more people. So that tells you who and what. This next one is what we call hot zone compliance. This hot zone compliance is to understand in a zone, where am I compliant to the rules that I'm setting? If I say that there should be only X number of people within so many feet, we need to be able to track that by zone. So the green zones say, this is good. I think it's okay. These are places that are all right. But the orange ones, I might need to send a security person down and tell them to disperse because they're disobeying the rule that you might have set for your institution to be able to do this, right? So it's a very proactive way to do this because this is something that can be generated live. It is live data that is always changing to be able to give you the idea of what's happening, and you can see the effect of the devices that, in terms of the proximity, are with each other. So you can look at that. You can look at the non-compliant zones. You look at all the zones. But the key here is to be able to identify very quickly where the hot zone is. By the way, and I'll talk about this in another future slide, but just think about the effect of being able to not only be reactive as we're seeing here, but if a student wants to be proactive and they're going to go into, again, as I said earlier, like the student center or the cafeteria, you could have an app built, push the button, and it'll tell you, is that zone compliant or not? So now you're bringing in the other people to be able to tap this data very quickly so they know what is possible in terms of where they should go if they want to be COVID compliant and not COVID compliant in terms of the rules. The last thing is to alert on the hot zones, right? It's one thing to identify them, but being able to look and see how long the duration has been and how many people have been there, the density to see in this case. Like if you look at the bottom number 13, you can see there's a capacity of 40. it's orange, and for 13 minutes there were 36 people in that zone. That's way too many people to be in an area if you're going to be worried about it, right? So it should automatically alert you and tell you that these zones, again, shouldn't be something you have to look up. You shouldn't have a a engineer sitting there monitoring something. It should be something that would notify you, right? And that's what happens here. So when you're looking at this, and whether you're looking at our platform or anybody else's, there is an industry best practice that we've tried to put together, a checklist. And so as you're looking at what's possible here, you'll see this matrix would be helpful to you, right? The live view, for example, being able to see where Wi-Fi, BLE, mobile apps, as you saw, are there. The client zones by computing, the hottest zones, the ability to provide 30 days of analytics of all data, not just Wi-Fi, all data, and make it as a part of just an endemic cloud-based, simple to get to information source. Locate users with Wi-Fi, be able to take and look at the user's journey and proximity tracing. So these are all things that you should see, and a lot of vendors won't be able to do it, but you should at least use this as a checklist to think of the things that if you are going to implement an AI-based contact tracing method, this is the way to do it. Now, I talked a little bit earlier about the fact that Wi-Fi should be a lot more than just a commodity where you use it to get onto a network, right? The contact tracing stuff I just showed you is an example of what I call the art of the possible, right? That really is just an offshoot of the wayfinding capabilities that we have in our device, again, because it's been built with that in mind, right? The Bluetooth is integrated tightly with the Wi-Fi, and it's all going to the same cloud, so it's very integrated, right? And so we have universities like University of Texas Arlington, who has replaced their whole infrastructure with us now, and they're using it to build applications to do campus guided tours without having any problem in terms of not having to have somebody escort them. You know, they can actually say, here, go from here to here, and a map will show up of the campus, and as they enter a door, it'll go to the floor version, and they can go find people. They're able to demonstrate, for example, instructor locators. If a student can't find where their instructor is, and it's not in their office, maybe he says, hey, come meet me here. And he can now get a map of exactly how to let their student go from point A to point B. And it will track them through with real time to help them walk through. That's because of being able to provide this wayfinding capability. We talked a lot about the tracing already, proximity notifications and contact tracing. Huge, huge, huge differentiator. In fact, like I said, we've had institutions such as Winston-Salem who actually use CARES Act money to do this, just to do this. And as it turned out, they used it to replace their whole Wi-Fi network to be able to provide this platform. Now, I'm a faculty person. I've been a faculty person, so I'm always one of those that focuses on what more can somebody give me to help me grade and be more efficient as a professor. Well, the ability for roll call to take place. Imagine, if you will, having your student, the minute he sets foot in your class, it tracks how long he's been in the class, if he left early, which helps me to be able to do it, and then be able to take and with the knowledge that you could have this SDK let you write this roll call application with the ability to now say, you know what, I want this integrated with Blackboard. So I don't have to do anything. It just automatically records what my students have been doing in terms of how long they've been in my class or where they've gone, or if I dispatched them to the tutoring location, I could very quickly see, maybe I say, go to the tutoring area, you get extra points, right? So whether it's Blackboard or Canvas or whatever LMS you want to use, we specifically allow you to have the data that can then be put up there. Now, we don't provide this app, but this is one of those things that can be done. This parent update was something that was very interesting to a lot of folks. And that is that, people send people to their university. The parents specifically spend a lot of money. And there's been more than one story I've heard where, the student goes to campus, but never went to class, spent the time partying, never even showed up on campus, just spent the time in the dorm. And the parents are furious. Well, this gives the ability, again, if you decide you want to be able to tell the parents, hey, the your new student hasn't been on campus for the first quarter. As many of you know, in the higher education world, the best time to lose a student is probably in terms of from the campus and in terms of them disengaging is probably in the first 3 months. And so you're able to, what we do, create something to say, hey, these students that are in, but that haven't been on class, in class or on campus, deals with to be able to, your ability to tell them, hey, is there something wrong? Are you okay? You haven't been to class or on campus. This is something that can be proactively done. Um, whether you're talking about libraries or tutoring activities, the ability to track, for example, students that have gone to the library, which helps you get your library funded, right? The usage of the library is always important, but it allows that dynamic reporting for the library, the tutoring activity, knowing how long they've done it, and being able to track the number of hours and minutes that they spent in the tutoring area, and then maybe correlate that to the grades, which will help you for educational outcomes, make sure that that the tutoring is actually helping them improve, right? So there's things like that. The safety aspect was something that came up many, many, many times. Being able to say, if we do have an active shooter, and by the way, let's say that one of those IoT devices is a gunshot indicator, to be able to know every device that's in an area actively, or if a student calls, and this is one that just came up in a call the other day where they really liked this, being able to say that the student calls security, says, hey, there's somebody following me. I don't like this. And I feel bad, right? So security is being dispatched. Well, in general, I don't know about you, but I find that if I know I'm in a dangerous area, I'm going to try to get out of the dangerous area as soon as I can. And the ability for our, on campus to be able to know that this person is going here to here to here to here to make sure they're safe, you'll know where they are, to be able to go and go after this person to protect them if they're feeling that, that vulnerable at that point in time. Other applications are deal with, for example, we have university hospitals, and in some situations they have Alzheimer's patients, and they'll put a Bluetooth lanyard around that patient, and if the patient in the Alzheimer's ward starts to roll toward the door, then the door automatically shuts and locks, right? So it's just unique usages. That's something they're doing at the VA hospital as well, but it's university hospitals look at this if they happen to be doing something with Alzheimer's. So this is about microservices in a cloud, be able to write applications that could be on a cell phone or part of a dashboard that you have for certain people that are behind the wall, right? So this is the communication that can take place. This is where I see Wi-Fi joining up with AI to provide the data that transforms Wi-Fi from just being a way to get on the network to something that is actually a true asset that you can use to leverage to do other things. For example, keeping and helping with student retention, which is obviously the number one thing we want, to be able to provide that kind of information to help them want to be more in tune with our universities. So this is kind of a summary of the way this thing works. These three things that we have congestion alerting, journey mapping, that proximity tracing we talked about. All of this is tied together in the cloud by this, Wi-Fi 6, Bluetooth array enabled, and telemetry antenna enabled access point that gives you the ability to use this SDK, which lets you build any application you want on all that data that's sitting up in the cloud, to allow you to combine people that are wearing tags with Wi-Fi devices, where something might be a lanyard or something on the back of a badge, to provide this Wi-Fi insurance, be able to understand the premium, the analytics that go behind it, the user's engagement, and the asset visibility on a single map. One of the last slides that I have here, and Michael, I hope I'm not going over. I think I'm just about near where we can take questions. But when people ask me about returning to work, and specifically the reason they want to is because a lot of times the services that are offered on the campus are better, right? If you have to always be on a certain server, or you have to have a certain um, set of devices, well, that's why you are on campus. And so typically there are three ways that people look at it, right? There's the VPN client method, where you just you're out there, and what we do is we put our Mist AP out there. That's we have lower cost ones for home, and you can put this Wi-Fi access point out there, and they can connect up with their VPN client as normal. The best part about it is it's not like some other things. Even if you get something from Linksys or one of these things like that, you're getting zero touch provisioning. You get the secure Wi-Fi, but you also give that user a better insight. So that's kind of the least method of doing it. What most of the universities that are trying to do stuff with us are doing this, the middle section, which is a remote faculty with auxiliary devices. And so, for example, your Cisco phone or your PoE phone can now be connected directly in the access point sitting at home. But the big differentiator is being able to drive with our VPN concentrators. Again, no VPN required. Keep in mind, the middle section means no more managing VPNs and trying to figure it out. This person is now an official extension of the university. And whether it's a student or not, you can create a separate student network. But it could be something that you say, here's how we're going to do this. And so we have this the software that goes in the data center itself. The device is at your home. Again, because of the fact that you're using this Mist Edge partition, you're able to now connect your phone up, and all of that goodness I talked about with AI and data collection is here, because now you're able to extend the actual school's SSID and AAA service directly to that person's home without doing anything. It's all zero touch provision, and you have the maximum security you can get with an IP in the IPsec tunnel that's taking place. So simple, quick, very high performance. In fact, we have a situation where we had an instructor, and this is at Juniper, by the way, one of the teaching people, that was having a bad Zoom experience. And so usually IT help desks at any place is not saying, oh, well, it's your network, you go figure it out. And you're kind of left to flounder. And in the teaching world, that's horrible because, if you're trying to teach students remotely using Zoom and you're not having a good experience, you're affecting their ability to learn. Well, in our particular case, we can quickly look, and what we're able to say, hey, let me take a look. Oh, I can see immediately, and this took about 15 minutes to diagnose. We found out that there were the DNS request to their home gateway was being overwhelmed by Netflix and and some other streaming services that they had. And this happened to be happening because their kids were doing all this stuff while he's trying to teach his class. Well, by extending the corporate SSID and the AAA service, giving it priority traffic, now he was able to complete his teaching, because now he says, okay, when I'm on and I'm on this, I have priority with what's happening here. And that all starts with just, again, putting a Mist access point at the home, but then combining it with the Mist Edge software that's in the data center. The last one is a super high performance solution for researchers. So we do a lot of work with research and education networks, and we have a lot of people that are using downloading terabytes worth of data. You have to worry about the security in terms of what's going in and out, right? And so we can actually create our DMZ, extend that DMZ all the way to the person's home, and now a remote researcher with a little SRX, or it's our security router sitting out there, connected out, gives them that high performance bandwidth all the way back into the cloud, back to the data center, right? So this allows you to implement even a higher level of security with a higher performance, instead of having to have every single packet inspected. You're able to say, these packets are data trusted packets, and they can immediately be passed through and not have to go through any further inspection. You create like what I would call the guys at the security at the airport, right? You can go through there. If you have it, you can go out and go right on through. Well, that's what this happens here. Allows you to do something like that. The last slide I'll talk about, and then we'll just open it up for questions, Michael, is the whole CARES Act fund, right? So whether it's elementary, higher education, or the governor's education relief fund. Now they all have different dates of when you got to get it done, but we have found, and I have a list of every university of what they've got. There's a education fund of 14 billion. If the university hasn't taken advantage of it yet, I would be surprised, because at least half of that money has to go back to tuition and room and board and things like this. But the other half can go for anything specifically anything that allows you to mitigate coronavirus in terms of the on the campus. And again, that's where I told you about Winston-Salem, who actually used the CARES Act money to completely refresh their network with everything I just showed you, to be able to let them know, wow, I can now do everything I want to do, have these other applications, and I was able to get the CARES Act money to fund it. So that is it for me. I don't know, Michael, if you got any questions, I can hang on. Happy to anybody who wants to meet me. I think you saw on my phone. I just as Jacob had mentioned earlier, I'm big on connecting with LinkedIn. So please, if you see my, I'll stop sharing here on my screen. You can see my QR code up there. You can click me if you would like to be connected up. I usually post a lot of content and what's breaking. And again, I'm not a sales guy per se. I'm a technologist. So if you ever just want to have a conversation with me on a technology perspective, I'm happy to be a part of that. So Michael, what do you, any questions
Yeah,
that you would like to have?
there are a handful of questions, and let me just add to those that are watching. If you have a question as we go through the Q&A portion, feel free to put it in the comments of the video, or message our CIT page. We're trying to keep track of them, and we'll ask the questions as we see them. The first question had to do with HIPAA, and you addressed that a little bit about the privacy of the data, so that contact tracing aspect. But let me expand that question a little bit on, it would be one thing if you're asking employees to do these things. It seems like another layer for students in the schools that have implemented that. Have they had privacy concerns, or have they had an adoption challenge of students either using the app or having the ID with them that would have the chips in it to help?
So the answer is, as far as students being worried about the privacy concerns, right? And there's a million conspiracy theorists that would tell you that this is just tracking me. Again, as far as HIPAA goes, first of all, let's be clear: we're not communicating any individual's name, right? This is why the way it gets put together is you can track devices, you can know, and it's HR's job to be careful with that data. Again, when they communicate when they communicate to students that they've been around, you're not saying, "Hey, you were in close proximity with Betty Jo, and she has COVID." So that's why that's anonymous. It has to stay anonymous. In the case of MIT, they specifically make it an opt-in process, right? So again, so the debate that I've seen, and some are much more conservative than others, but the ones that are trying to create their own defensible campus, what the reasoning they have is that you're on my campus, I need my campus to be safe, therefore I need to know everybody that's on my campus. And that's a legitimate concern, right? You want to know who's on your campus. That's why you have areas where you say you can't come on here, can't come into this building unless you have this badge. Well, that's the same theory that they're using. So far, not. I mean, the fact is that a lot of this is passive. If they're a part of the university architecture, they're developing apps that say, "Hey, here's my Bluetooth app. When you're on campus, you do it this way," or they just give them the badge and they say, "Hey, you just so you know, when you're on campus, you should have this badge." That isn't to say that it's 100%, because, as you know, if students can get around a rule, they will. They just will. And so, but it's better than nothing at this point to be able to have this, especially for at least the university employees, right? The students are one piece of it, but the university employees need to be protected as well. And so that helps them to get that. So at least you have probably 80 to 90% compliance usually in that world.
Yeah. Another question we got is on the Wi-Fi part. Does it have to connect to the Wi-Fi network for it to be sensed, or is it can it detect Wi-Fi enabled devices that are in the range?
Yes, and so the answer is it does not have to be on. This is one of those five metrics that I mentioned as far as the components, and that component is called an unconnected Wi-Fi client. As you know, Wi-Fi will just be off, and as far as not connected, it's broadcasting, but it's not on your network. And so those can be detected, as opposed to even like my watch here, my Samsung watch, it's always chirping Bluetooth, always, 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 always. So there's no control there. I mean, and so we picked this up immediately. Wi-Fi off of the phone can be usually connected, even if unless they turn it off, obviously, like any device. But yes, so unconnected and connected clients are both tracked, as long as it's broadcasting.
That's right. That's right. Well, it seems to me that just that level of knowledge from a marketing is not the right term for higher ed, but it's almost about seeing traffic patterns, seeing marketing opportunities, and on a campus that all the student flow goes down through that sidewalk at this particular time. Just little things like that that could help efficiency aspects of a university. But think, and I know your expertise is higher ed, but think outside of higher ed. What are some of and outside of contact tracing, some of those use cases that you've seen in other industries? Seems like retail could be valuable.
So I was going to mention that one. So that's one of the big reasons Walmart chose us, was the ability for them to be, that whoever's in their store, to know where they're going, where they're lingering. That tells them, oh, if you're always over here by the GNC part with the this, that they're probably looking at those things. And so it helps them with that traffic flow. Amazon Distribution Center, to understand where things are going on, where not only their asset devices, where the people are involved in that one too, right? So that's those are all. And retail is a huge application for us. We're talking to some. I won't say who they are yet because it's not finished, but you've got people that are in, let's call it the entertainment industry, where you've got a theme park of people traveling through the park, and you want to know who's going where, and just being able to have a global view of what's happening and where people are is important, right? So those are those kind of applications that are very different than just the big point is, once you realize what data is up there, it can go and be used for anything you want to use it for. And retail has been a big one. The service industry has been a big one as well. And obviously, we talked about Amazon.
So if you were deploying that on, an average college campus, and you were, you're coming out to install, you talked about the setup being much less than some of the competitors in that particular scenario. What's the biggest, not financial, but in a deployment standpoint, or from a deployment standpoint, what's the biggest time piece of deploying that wireless technology? Is it the to get the Cat5 to the location?
It's the mounting and initial hardware connection is where it turns out to be. As you know, dorms, for example, we actually finally developed a dorm one, because you want to put it in a flat panel. Not everything can go on the ceiling. But the majority of the time is mounting and plugging in and making sure that you've got your switch just plugged into the network, right? And again, that's where our AI piece comes in, because even in our switches, we recognize where all the access points on the switch. You can immediately see where it is from a global view. You don't have to, again, do anything, because once it gets this information to the internet, that device is up. There's nothing you have to
do. Yeah. I mean, that seems like, and then, if you're, what was it, 9,000 devices, I think you said, maybe it was MIT.
Yes.
It took you 3 months to do that one?
Well, I'll give you better. I think Walmart rolls out 1,000, I think over 1,000, I think they told me a day, 1,000 access points in a day. Again, it's just mainly plug in, plug, go, and you're done. See, the big differentiator is when you're in a controller architecture. And I used to be at Brocade, where I had to deal with ruckus. You're doing all this stuff behind the scenes to architect that this is an access point. It's got to come up. I got to create this tunnel through here, and you got all this extra stuff that you have to do. And then you have to create that interaction between that controller and the master controller. And then if you want to do any kind of device stuff, like you have to buy CAPE sensors, for example, for some, just to get the telemetry that's automatically in our device, right? So that's the big difference here. You don't have to do any of that. It's just up. So it's mostly the physical connection, maybe some mild stuff in terms of how you want that access point to communicate back in terms of what data. You can certainly modify all that, but out of the box, most people just turn it on and it's going.
Okay. Well, that certainly makes sense. Well, let me ask, I got one last question here for you. It could be a complicated one, but we don't have to get into the weeds. Going back to the privacy piece.
Yes.
The short version of the question is, have you deployed in Europe? And the longer version of the question is, and I realize that you're in the Americas, but is the privacy rules that Europe has implemented, does that change that privacy dynamic any, or does it require additional opt-ins?
Yeah, well, so here let me address that in two different ways. Okay, the first one is, for example, Oxford has just announced they're going to go with us. Now, that their privacy rules are what they're going to implement at the in terms of what and how they deal with the backend information. That's one side. That's different than like Canada, where Canada are hypersensitive about where data is stored, and the fact that our cloud is in the United States. They want no data to leave from Canada to come to the United States, even though it's only telemetry data. It's data that deals with movement or whatever. They don't want that, right? So as we deal with Canada, we're about ready to open up a cloud entity in Canada to be able to allow Canada to do what they need in Canada, right? So that's their privacy, is they don't want data, the big chunk of data, to be moving across the border. I haven't found that to be the case over at Oxford and EMEA, those countries, because they're constantly buying things and they seem to be okay with what's going on there. I haven't really noticed anything that said, hey, we can't do this because you are broadcasting to the cloud. Canada was different. And so we do have some universities that are absolutely wanting us. They're pushing for that rule, and we're going to try to help accommodate by putting some of the cloud pieces in Canada so that their data doesn't have to necessarily traverse. Keeping in mind that hopefully all the goodness that we get here with all the people in the cloud with us to create that machine learning to get better and better and smarter every day, they'll still be able to take advantage of it, even though that we'll push them what we know. There may not be a lot of pushing coming in the direction.
Gotcha.
That helps.
Gotcha. Well, that's interesting. I wouldn't have thought about the cloud, the going across national boundaries, but that's an interesting piece as well. Well, I am sure there'll be others that come up with questions as well, but those were the only ones that I'd seen so far. But with that, I'm going to say thank you very much for your time today.
And I do want to make an offer. If there's anybody who wants to try this out, I think we've got a program to give somebody a free access point and things like this. I have to check to see how. Like I said, I'm not the sales side, but there's things like that. And the best way to experience this is to just put it in and let us show you, because once you experience it, it's amazing. It's very different than anything you had when it comes to being able to manage a network, not just the Wi-Fi, but the wireless pieces and all those things with AI. It's really dramatically different than anything in the past. So I'll make that offer. Anybody who wants to do this, just ping me and I will be happy to get you the demonstration or some device to play with. Happy to do it.
Awesome. Well, thank you very much for that.